Welcome to the Byrne-Wheeler Report. We're recording this on the 27th of July, 2026. As always, good to see you, Bob.
Hey, Joe. Happy Monday.
Happy Monday. So I just wanted to mention to our viewers and listeners that the Byrne-Wheeler Report is now available as a podcast for people who prefer to get their content that way, so people can listen to us in the car or when they're walking the dog. We've got some events coming up this month. I'm going to attend Hot Chips, and then Bob, you are going out to OCP, right?
Yes, so I'll be at the OCP APAC Summit in Taipei on August 11th and 12th, thanks to Light Counting. And I'll be moderating panels, one in the photonics session or track, and one in the chiplets and advanced packaging track. So should be an interesting 2 days there.
Definitely sounds like it. So I guess our faithful viewers can look for you there and meet up, buy you sarsaparilla or something.
And you will be in Stanford.
That's right. I'll be at Stanford and attending Hot Chips. And again, people can look for me there. I may have do some cell phone based video while I'm there. I mean, there are a number of talks at Hot Chips. Two that I'm interested in hearing more about are from Intel. One is about Diamond Rapids, which is their next performance core based Xeon that should begin shipping next year. And then the other is about their Crescent Island GPU. It's been a while since Intel's done anything on the accelerated compute AI processing front. So very curious about what's going on there. And then the third thing I was interested in was we've talked about this in the past. NVIDIA has their LPX design based on the next, or maybe it's based on the current Grok LPU, their what we would call an NPU, their neural accelerator. So it'd be good to get some details about that. Anything about Hot Chips grab you, Bob?
Yeah, a few things that look new. Yeah, Crescent Island, I mean, we know virtually nothing about, so that will be very enlightening. Also in the GPU session, I saw that AMD is going to be talking about the MI400 system architecture, so that should be interesting. A little more detail on the Helios rack architecture, I'm guessing. And then on day 2, there's a networking and interconnect session, and most of that is sort of well known, but one topic that's quite hot right now is actually micro LEDs as a very low power, short reach interconnect, and Mojo Vision will be giving a talk. So that could be interesting. And then in the there's an afternoon AI session that includes some of the hyperscalers, the MTIA, not sure if there'll be anything new there, but Microsoft's going to be talking about the Maya 200.
200, right.
There could be something new there. And then finally, Google is going to be talking about the 8th generation TPU family. And, you know, there's limited detail on TPU V8 out there right now, so I would expect there'd be a few nuggets of new information in that talk as well.
Yeah, I'm looking forward to that. They put a big paper out, maybe TPU V4 or earlier, and that gives you a sense of how the details, and then each time they do a release, they make some indications about some of the bigger changes. But this will be good to kind of sync and see what's really changed and what some of the details are now that we're at the 8th generation.
Yep. So those are the highlights I'm looking forward to.
Yeah, it should be good. I mean, you're attending, right, just remotely, whereas I'll be actually there in person.
Correct.
So I think we'll have a follow-up discussion about both these shows in August. So as for our agenda today, AMD just completed their AI Day, which is kind of their developer forum / pep rally, but given the world revolves around AI, it's AI centric. We'll talk briefly about the NVIDIA Vera microprocessor, Astera, Taurus, and then we'll wrap up with a few comments about the Google earnings disclosure. So, Bob, you mentioned the Helios details being disclosed at Hot Chips, but we know a bit about it already, and I was asking you some questions the other day. The most noted thing about it is that it's based on the Open Wide Rack standards. My questions for you are, why would they use a wide rack, and maybe what does it spell for the future, and what does it indicate about some of their networking topologies, whether it's the scale up or the scale out, or limitations there too?
Yeah, so I think it primarily reflects the the reality of the scale up interconnect. So they say that the MI 450 has the same scale up bandwidth as is NVIDIA's Rubin. And of course, Rubin is using 400 gig scale up. We think it's really 200 gig simultaneous bidirectional signaling, but net, they get 400 gig per lane. And AMD is only at 200 gig per lane. Therefore, they require essentially twice the number of backplane interconnects to get the same bandwidth. And to fit that in a standard ORV3 rack, I think would be very challenging, along with all of the switch silicon on the switch trays and all of the connectors and everything. So by going to the wide rack, that gives them a little more space for the scale-up interconnect and specifically the backplane connections. It's Tomahawk 6 on the switch trays, so it's 200 gig per lane. And then using what AMD calls UALink over Ethernet, which is, by the way, not a standard, but
right. Okay.
AMD uses that terminology to make it
UALink's
like
a standard. Ethernet's a standard. So
yeah, right.
So the cross product of them must be a standard. It's only logical. A standard that one company uses.
Yeah, it could become a standard through OCP. The so-called SU-T effort in OCP, but it is not yet. So
right. Okay. I mean, the disclosure of Helios, I guess the real announcement is they're actually shipping it. It wasn't exactly new news that they had Helios and that, it was going to have MI 450 GPUs in it. And so that wasn't exactly new news, nor was it new news that they would have a next generation EPYC. What they have done, however, is they've disclosed the rollout schedule for it and the initial models for EPYC. What I noticed there, if I can consult my notes. So they've raised the maximum power. So at the top of the SKU stack, they've gone from 500 watts to 600 watts. And that enables them to get the 256 core CPU that, they had said that they were going to develop. I think I think something that they hadn't disclosed previously was the amount of L3 cache. So even though this is based on the Zen 6C or compact core, they've also, compared to the compact chiplet in the prior generation, they doubled the L3 cache per core. So they're now dealing with like 4 meg of L3 cache. So we now have a microprocessor with 1 gigabyte of L3 cache, which just seems like a phenomenal amount.
And that's not the 3D, and that is not the 3D stack version.
No. So they did disclose, or they said it's not shipping. They didn't provide any model numbers or whatever, but they did disclose that they'll have a Venice X in 2027, and that's the V cache or the 3D chiplet version. And it'll have about the same L3 cache. It's 1152 megabytes versus 1024, but it will have only 96 of the CPU cores, and they'll be the faster Zen 6, non-C version. So that's for HPC and scientific computing, technical computing applications.
Yeah, just to show how long we've been following this stuff, when I heard 512 threads, my head wanted to explode. It's like,
yes,
that used to be what we talked about for network processors, right? And now you've got a CPU with 512 threads.
Well, I mean, we have enough gray hair that it was sort of like chips per CPU, like in the bit slice days and before, and now then it was like, okay, microprocessor, one chip, one CPU per chip. That was great. And then, dual core. And now we're at 256, which is hard to imagine, but there's a class of customer for which it means that instead of having, you compare it to 256 servers, you can have one server that serves 256 individual clients, let's say, or virtual machine. Let's see, what else did
I mean, the main part of the EPYC story seems to be just, AMD's continuing to take advantage of the chiplet architecture to do these different variants that are tuned for different.
Exactly. So, we mentioned there's the compact version and then the non-compact. And so that's sort of like one set of variation. And then there's the ones with the stack cache. And then another thing is in the past, they had like the NEBS friendly telco versions of EPYC, which had fewer memory channels and they were in a smaller but still pretty huge package. They're now announcing that all at once. They don't have a separate code name. They start with the EPYC 9000, not EPYC 8000, so they're more like folded in. And it's sort of, do you want the big SP7 package, or do you want the little SP8? And by little, the little one has 8 DRAM channels compared with 16. That's huge. And in fact, the smaller package, there's a SKU with only 8 cores, so you can get 8 cores and 8 DRAM channels. And like a microprocessor, if you need a lot of DRAM bandwidth per core, that's your choice.
Didn't they also mention LPDDR?
Yes. So that has a different code name, even though it's still Zen 6, and that's Verano. And that will be out next year and will ship with the next gen Helios, which is the Helios 500. And that is AMD's EPYC to NVIDIA's Vera, where instead of using DDR, it's going to use LPDDR. And instead of having only PCI interfaces, it will have the XGMI interface to talk directly to an AMD GPU, which sounds a lot like 10 gigabit Ethernet media independent interface, but it stands for something completely different.
Yeah, also known as Infinity Fabric.
Also known as Infinity Fabric, right. But I think it's semi-open and standardized with the alphabet soup designation. I don't know.
It is the basis for UALink protocols. So
okay, yes. So it's basically standardized.
Yeah, but interestingly, they're saying XGMI. They're not saying UALink. So
yeah, that is curious. And maybe sort of like an L1, L2 versus like L1, L2 versus an L3 comparison. Like it's more about the physical and link layer than I don't know. I mean, Infinity was a strange name considering they assigned specific speed to it that was somewhat less than infinity. It's like the never-ending story being a 90-minute movie. I feel kind of like it should have been longer.
They also talked about the GPU roadmap a bit. You mentioned MI500, which will have HBM4E. But the other interesting thing is they claim it's going to have leadership in the scale-up domain size. The question is, how do you parse that, given that NVIDIA has talked about an NVL 576 configuration for a Rubin Ultra? Are they suggesting it's going to be bigger than that, or are they actually just talking about at the single rack scale? And I think we don't quite know the answer yet. But interestingly, they mentioned enabling both copper and optical interconnects in the MI500 generation Helios. So that suggests multi-rack configurations.
Yeah, so if they're at 72 GPUs per rack, and they could scale that number up, then you could get past 576 if you go multi-rack for sure.
So just a little tantalizing tidbit there without any detail.
Yeah, I mean, one of my takeaways about the EPYC and the Instinct GPU roadmaps is EPYC is on a 2-year cadence, so they disclosed they're working on a Zen 7 based EPYC, which given that they just started shipping a Zen 6 kind of makes sense. And then that they've begun work on Zen 8 and they're slated to appear on a 2-year cadence, whereas the GPUs are being updated annually, which, I mean, I think that reflects the market demand at this point, the competitive pressure.
Yeah, and they actually mentioned that MI500 would deliver greater than 2000x inference performance specifically in a 4-year time span. So I think that compares to MI300. I don't know if you were able to do the math to reverse engineer that. Okay.
No, I haven't backed that out. Usually, first thing is the precision reduction. So you go from like FP16 to FP4, usually you get a 4x throughput, and then you get a scale up. So until this current generation, their pod size was 8 GPUs, and now they can do 72, and now they're talking about, leadership scale up. So they could be comparing the full scale up domain from start to finish.
It's supposed to be an end note. I didn't go looking for it.
Right. It was in fine and not high contrast print. So it's on my to-do list. I've written up the EPYC. I'll get that posted to xpu.pub. It was going to take a little longer for me to go through the GPU changes.
You are right, Joe. They say peak theoretical precision performance of MI500 powered AI rack versus an Instinct MI300X platform. So you're right. They're including the 72/8 factor. I'm sure the precision factor. So you can kind of take those two out and then take it.
I mean, the problem with 2000, usually if it's like 100, you could kind of back it down into multiples of 3 and multiples of 10. You get to 2000, it's hard to kind of figure out everything that stacks up to get there without like really sitting down and parsing it out. And at the end of the day, nobody really cares how much faster it was than MI300. People want to know how much faster it is than NVIDIA.
Yeah, exactly.
And so let's see. Compared with Rubin, it's slightly more raw performance, but similar I/O and bandwidth. But they've reworked their architecture, including the memory hierarchy, and they've added capacity to the different structures, whether it's caches or shared memories or registers. And they've redrawn some of the boundaries around what's shared at kind of like what level in the design hierarchy. And the idea there is they're reducing redundant data traffic. So they're going to get performance gains that are separate from like the raw flops improvements. So like there can be additional factors there. And then they copy features like NVIDIA early on, relative to AMD, had tensor engines in their GPUs and then they had data movement primitives or hardware, and now AMD has added that, and AMD's reworked the DMA and things like that. So there are a lot of things where they're following the lead of NVIDIA under the hood, and where they're looking to address kind of performance bottlenecks that exist independently of the amount of compute resources that are available. And let's see, they blew a kiss to their Pensando DPU NIC products, but they didn't really go into details. I mean, they have a roadmap, but the roadmap consisted of, hey, we've got a new code name coming out next year, which is not exactly shocking news.
Yeah, I mean, they didn't even put a bandwidth figure on it, so it's hard to get real excited there. The claim to fame on Helios is that they have 1.5x the scale out bandwidth per GPU compared with Rubin, with the Vera Rubin platform. But it doesn't come for free. They just have basically 3 NICs instead of 2 per GPU. You need more optics. There's a cost associated with that, and I'm not really sure what the return is from a performance standpoint. It's nice if you need it, I guess, but not clear what it actually delivers in terms of ROI.
Hopefully they are working with customers and the customers are telling them like, hey, we've been using your GPUs and this is run where we see like, idle times or wasted compute cycles or what have you. And that's what's driving a lot of these decisions.
Yeah, hopefully there's some real reasons behind it, but they haven't articulated that very well.
They haven't articulated them, no. They did. Speaking of customers, in the days running up to the event, they announced that Microsoft was going to be a customer and an investment and customer deal with Anthropic. And the latter one had a gigawatt value associated with it. The Microsoft one, didn't, but at least they named specific instance types that Microsoft Azure would offer. So it seemed real, but in some ways maybe less committal regarding the total spend that Microsoft is going to make.
Yeah, no scale at all, no schedule, I don't think, as I recall. So it was a little disappointing to not have anything solid in terms of the scale. And the Anthropic one, as you point out, was, up to, which gives them a little bit of wiggle room as to actually what they are going to deploy, as well as the investment side was an up to figure as well, which is a little strange.
Yes. I mean, I think some of it is that they're contingency. So, if you deploy this much of our stuff, then you get the next tranche of investment, something.
So the lawyers made them say that, is what you're basically saying.
Yeah, but I think also practically speaking, they don't want to commit to $5 billion unless like they're getting an ROI on the initial. They're accounting things where they can't make it 100% contingent, because otherwise it's like you're giving them money to buy your stuff, and then you have, like, they want the accounting treatment to be not like an expense or a discount, but rather like an investment. So I'm sure there are all sorts of carefully phrased contingencies and rules about this, but they're not just chucking the money at them either.
Yeah. Anyway, it's significant. I mean, Anthropic clearly is getting compute wherever they can. Interestingly, Google, during their earnings call, mentioned that they began shipments of TPU systems to external customers this last quarter. So Anthropic, of course, would be at the top of that list.
Yeah, let's use that as a segue to talk a little bit about the Google earnings. I know I said we'd talk about it at the end, but since it's come up, they had a big revenue growth quarter. I think it was something like 82% year over year, and they raised their CapEx by about 10% for the current year. Anything else you noticed, Bob?
Yeah, and they had negative cash flow for the first time since they went public.
Yeah, negative free cash flow, which it means that they're investing ahead of what they believe to be future earnings. They talk about having a $500 billion revenue backlog for the cloud business. So I think with that backlog, they feel confident about investing.
Yeah, well, I think, Wall Street is going into kind of a show me mode now where the companies are not being rewarded for investments in future growth necessarily. So
yeah, and I said, my concern is so GCP, the Google Cloud Platform, they had this 82% growth. That's $11 billion. And that includes TPU sales as well as cloud services. Now, Google has this agreement with Anthropic that you mentioned. That's a $200 billion over 5 years, which is divided out. That is $10 billion a quarter, which is approximately exactly what Google Cloud revenue grew by. And if you think also about that $200 billion and compare with that $500 billion backlog, that's 40% of that backlog. Now, some of that's been spent, so maybe it's really 35, but, Anthropic is a big chunk of the Google Cloud story at this point.
Yeah, I mean, they did say that they're expecting a relatively small portion of the revenues from system sales agreements this year, so they're kind of looking at it as ramping as they exit the year. So I don't think it's going to be that significant that it would have kind of offset the GCP growth.
The TPU sales proper, but if they're leasing any TPUs out on a services basis, that would be counted. And I mean, they're doing business with Apple and Samsung and so forth too. But I mean, going back to the show me, I think there is concern that the current big market is really being driven by OpenAI and Anthropic. And so that comes back to the show me as people get concerned about those two specific AI companies.
Yeah.
Okay. So speaking of bull, Bob, Astera announced the Taurus. Can you tell me? I literally did not look at that. I just see it on our agenda. So what is Taurus?
So, well, first of all, the Taurus brand is not new. Astera Labs has been selling their Ethernet products under the Taurus brand, and those are used in active electrical cables. So, whereas Credo sells complete cables, Astera Labs sells these little modules that are essentially the paddle cards that go inside the ends of the cables, and then they rely on manufacturing partners to make the actual AECs. So what's new is they announced these Taurus smart retimers and smart redrivers that are 3.2T devices. And what's interesting is the latter part there, the redrivers, because what Astera has done is they've created a single footprint where you can populate either a retimer or a redriver. And so these are 200 gig per lane devices. They're intended for chip down applications, meaning essentially on a PCB driving a backplane. So, typically a scale up type interconnect on a backplane. So you can imagine this sitting between an Ethernet switch like a Tomahawk 6 and the backplane of something like a Helios. I'm not saying AMD's using these chips. It's just an application example. And so it's 16 lanes of 200 gig device. And then in the same footprint, they have a redriver chip. And so retimers are full SerDes. They, do clock and data recovery. Redrivers are essentially analog. They're just doing analog equalization of the signals. And so the idea is that customers can design in a retimer and be kind of assured of the robustness of their backplane design. But then once they've qualified the system, they can, if they have enough margin in their design, they can actually replace it with a redriver, which would be less than half the power of the retimer, lower latency, lower power, presumably lower cost. And so it's a clever idea. The other thing I was not aware of is that there's actually an OCP spec for a footprint for these retimers.
Really?
And so Astera Labs is following the OCP spec for the footprint. So in theory, you could have multi-sourcing, which is another good thing. And then lastly, it's interesting in that this is the first, the redriver is the first silicon germanium device that Astera Labs has developed. So whereas the retimer is, of course, CMOS, the redriver is in SiGe for higher performance.
So the redriver will have higher drive power than the retimer, but it doesn't do all the full synchronization.
Exactly. It also won't have exactly the same telemetry features, although Astera Labs did some hand waving with regards to that because they have a sort of a common software called Cosmos that will support both, but what's actually implemented in the redriver has to be kind of a reduced function set just by virtue of the fact that it's in SiGe.
Right. And by virtue of the fact that they're not synchronizing the clocks and therefore able to meter kind of that goes into as precisely.
Yeah, that too. But I mean, it probably would require something like an external microcontroller to get all the full telemetry features that the retimer has.
Turning back to our agenda that we're executing out of order, we alluded to earlier about the AMD Verano being their answer to NVIDIA Vera, which was previously been disclosed, but NVIDIA has disclosed additional information about recently. Bob, do you have any comments about it, or do you want me to yak on?
The main thing is NVIDIA is really pushing this idea that there's this massive market now for CPUs based on agentic AI, and there's going to be this need for racks. They've put giant TAM numbers on it, as I think we've discussed in a past episode.
The principal role it plays is it's the host for their GPUs. So they've had Grace Hopper modules, or super chips as they call it, and then Grace
Blackwell.
And then Grace Blackwell, and now Vera Rubin, the superchip module where they drive the GPU with the Vera CPU. And so that's the principal application. And then they now have the MGX rack, which is an all CPU rack. And I think the big advantage Vera offers is its memory bandwidth, its on-chip bandwidth, and its I/O bandwidth, its ability to move data quickly to NVIDIA GPUs. So any application, rather, where you're bandwidth constrained, you're going to do really, really well with Vera because it uses LPDDR and it gets 1.2, 1 point something gigabytes per second of DRAM bandwidth. And it's a monolithic chip, so you just have to cross the on-chip mesh to get to the DRAM controller.
Yeah, and I guess the bad news for NVIDIA's competitors is they probably do have a better understanding of the workloads than anybody else in the space, meaning an AMD or a Qualcomm or an Intel.
Right.
When they talk about the sandboxing application in particular for agentic AI, it has a little more credibility coming from NVIDIA than it would from anybody else, where you feel like, well, are they just sort of making up a market that doesn't exist? And we'll see more in the future from NVIDIA, I'm sure, on what that actually looks like in terms of scale. I think AMD mentioned in Lisa Su's keynote that they think, I think it was this year, the market will be 60% inference and 40% training. So, I mean, there's this big shift towards inference. And then related to that, as you move to agentic AI, you need something to do kind of the orchestration. And that's where the CPUs come in. So,
as well as executing a lot of the functions, right? The agent will call a program. Let's say you're doing code development. There'll be one agent that will compile the code, maybe another one that runs a simulation or execute, like a profiles it. And, that's sort of the thing agentic involves is you're basically giving opposable thumbs to your GPUs so they can kind of be the brains that control real work that's being done by the CPUs.
Yeah. And so, I think we've only just scratched the surface of what that's going to look like in terms of the compute requirements as people start spawning, kind of huge numbers of agents.
Right. And then my other takeaway from the competitive landscape is, the discussion is really, is NVIDIA onto something? What does this mean for AMD? At least from the public discourse, Intel is largely left out maybe until last quarter. They were the biggest server processor supplier, but AMD has been growing. AMD's had a higher blended ASP. Diamond Rapids has been pushed off to next year. So it's kind of a strange shift in the discussion.
Yeah, but in the near term, rising tide lifts all boats, and Intel, of course, had excellent earnings. So as you say, we'll wait and see what AMD's look like by comparison.
Yeah, and to wrap it up, it's good talking to you, and I look forward to talking to you soon after we've gotten a chance to see what is disclosed at the OCP APAC and the Hot Chips conferences.
Yeah, enjoy Stanford. I know I'll enjoy being back in Taipei. Haven't been there for quite a while. So
bye, everyone. Until next time, be well.
It's all about the Pentiums, baby.